Now, when you're trying to solve a system of equations, there may be some cases where they give you one particular equation that has been solved for y, and the other is still in standard form. So when you have a situation like this, it's sometimes easier to use a method called substitution. So let me show you what we do in substitution. In substitution, we're going to take the one that has been solved for y, and we're going to place the value of y in place of y. So let me show you what that looks like. For instance, we have 5x plus y equals 4. So I'm going to rewrite this as 5x plus, and instead of putting y, I'm going to actually put what y is equal to, which is x minus 2. That eliminates one of my variables so that I can go ahead and solve for x. Once I solve for x, I'll take that value and put it back in the equation and figure out what y is. So for instance, I have 5x plus x minus 2 equals 4. In this case, this is a positive sign, so if we were to distribute it, everything would stay the same. So at this point, I'm going to rewrite this as 5x plus x minus 2 equals 4. I then want to go ahead and I want to combine like terms. So if I have 5 x's and I add one more x, it gives me 6x minus 2 equals 4. And then what I want to do is I want to put my constants together. So I'm going to use inverse operations to move my 2. So the same thing, right? If I'm subtracting 2 here, then I should be adding 2 if I want to get rid of it. That becomes 0, and 4 plus 2 is going to become 6. And I'm going to bring down my 6x, and now I can divide out 6. And that leaves me with x is equal to positive 1. So now I have one of my values. I know x is equal to 1. What I need to do at this point is now take this x value and plug it into either equation and figure out what y is. Now just looking at it, I think using this bottom equation, it would be very easy to get my answer using that one. So I'm going to rewrite it as y equals x minus 2. Since we know x is equal to 1, I'm going to substitute a 1 in place of x. So that's going to be positive 1 minus 2. And that'll just give me y is equal to negative 1. So now I have my solution set. I know my y value, I know my x value. So my solution set is going to be 1, comma, negative 1. So that's my solution. Now, what I'd recommend is if you're using substitution, once you get your solution, you should go ahead and use this and justify your answer by plugging them back into the equation to justify it, to make sure that it's correct. And I'll show you what that looks like. For instance, if I plug it back into the first one, I'll have 5 times x, which x is positive 1. And I'm going to write it on top so you see what I'm doing. 5x plus y equals 4. I'm using that equation. So I substituted my x value. I'm going to substitute my y value now. So I'm going to say plus negative 1 equals 4. And if I work this out, 5 times 1 is 5. A positive 1 times a negative 1 just leaves me with negative 1. That equals 4. And I have a true statement. And that's what I'm looking for. That it's whatever I get is true. I'm now going to go ahead and use my solution set to solve the second equation, just to double check, make sure there's no errors. So I'll end up with y is equal to x minus 2. My y came out to be negative 1. If I substitute my x value, that was positive 1. And then we had minus 2. And negative 1 is equal to negative 1. Again, that's a true statement. So I know that I've done this problem completely. So I worked it out. I solved for x first. Then I plugged in my x value, or substituted it for x, and solved for y. Got my solution set. Then I plugged my solution set in to both equations and found that they're both true. So I know that my answer is correct. And this is how you use substitution.